All right, so inverses, like I said, are when you, it's no longer what is sine at 30 degrees, it's where is sine 1/2, okay? So think about good old functions in the beginning of all of this, when we figured out if it passes the vertical line test, then it's a function, okay? Also, when we did inverses, we would say if it fails the horizontal line test, the inverse is not a function. So think about our spaghetti graphs we've been doing and all the graphs that we've had recently. Would those pass the horizontal line test? No, because the wave keeps on going, and of course, if I take a horizontal line, I'm going to cross in more than one spot. Okay, so we have to restrict our domains. So, like I said, inverses are hard. They really take a moment for you to have to like sit down and look at it, and not just fly through. Okay, because mistakes will happen if that's the case. So let's first look at the inverse of sine. So on your paper, go ahead and graph the sine function. Hopefully from memory. All right, so we have our sine graph. So if I was to take no. There we go. If I was to take a horizontal line, if you notice, I cross here, I cross here, I cross here, I cross here. So the actual function that we're looking at right now, the inverse is not a function, okay? So what we have to do is we have to restrict our domain off, so therefore we can still find the inverse, okay? So looking at this graph, and I'll give you a hint, we like to make sure we include the first quadrant in our restricting of the domain. So where should we restrict our domain so we don't fail the horizontal line test? Do it. Do it. From where to where?
0 to 2 negative. It's just negative pi over 2 to pi over 2.
Yeah. Negative pi over 2 to pi over 2. What that does is that's going to give me an option of all of my negative answers and also my positive answers. We always want to use that first quadrant, okay? So once we have restricted the domain, we're good. We're set. That is it. That is what we are restricting it to. So we already talked about here that no, it is not 1-to-1. And we are restricting our domain to negative pi over 2 to pi over 2. Okay, so you can see inverse of sine written with the little -1. We've been using that. Or arc sine.
What does that mean?
It's just another way to say
That was it.
it. Why did I, like,
I don't know, I'm right here.
right.
His voice is also deeper than mine.
What does that mean?
Yeah.
It's just another name for it.
Okay, so.
Yeah. You could see like arc sine of 3 degrees. I don't know.
Inverse of sine.
I think the next one is very repetitive, so we don't need to write that. So we find the exact values of the inverse of sine by thinking, where is sine? Fill in the blank. Okay, like if they're asking you, where is sine 1/2? Where is sine root 3 over 2? Where is sine blah 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 blah. Okay, so we've restricted our domain. This is where it comes a little tricky, but if you can get this part, the answers are quick. Just like when you first learned the unit circle. Setting it up at the beginning was kind of like, oh, what are we doing? And then afterwards, it's like, if I asked you for sine at 45, you can instantly look at it and say root 2 over 2. Okay, you were able to pull that information. Same thing when we're doing inverse, okay? So let's look at some examples. All right, so what you're going to do, and what I would suggest to do off the side, is make our own little mini unit circle. For those of you who are lazy and don't like to write things, this is not for you. Because you're going to write this. All right? And what I mean by that is, yes, it's annoying that we have to write it again, but it will help you out, I promise. So if we restricted our domain from negative pi over 2 to pi over 2, we're in that first and fourth quadrant. Okay? So we know 0. This, of course, is our pi over 6, pi over 4, pi over 3, pi over 2. But I can't call the next part 11 pi over 6. So I usually have this like spread out over the whiteboard, but I'm trying to have these recorded with kids being out lately. I cannot say 11 pi over 6. Why? That's over here. I've restricted my domain to just this. So I can't say that's 11 pi over 6 and so on, okay? What I can call it is exactly how we see it. Negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. So then now I have from negative pi over 2 to pi over 2. Okay? Go ahead and jot down your ordered pairs next to those. I said I don't have room on mine spread out. I'm not putting it over here on the side. Someone's listening in, just have your unit circle. also a good way to double check that you still remember your unit circle. Some of y'all got a couple of things backwards on the last test. Okay. Yes, it's annoying to rewrite that. Yes, it's like, oh my goodness, one more thing to do. But now look how simple it is to answer these questions, okay? So now I look at that first one and I say, where is sine -1? -pi/2. And that's my answer. You don't have two answers. You only get one answer. And the thing is, writing this out, like I said, is annoying. I get that. But on a test, in the middle of the test, I can't tell you how many kids tell me instead of -pi/6, they tell me 11pi/6. Okay? So when you're doing inverse problems, you need to make sure that you're giving me the correct one. Okay? So go ahead and do the rest of those. There are some negative things in there too, I'm sure. I've been saying that someone will take this up like yesterday, and then this is the next class. So I've been saying this so it gets easier to knock them all out at the same time. You're like, you just took that. I'm sure you wonder that. So just like when we made the unit circle, the process of it felt like, oh my goodness, what are we doing? We have to write all this out. But then once it's written out, you're able to pull answers pretty quickly. Same thing with inverse. I can ask myself the question, where is sine √2/2? And you would say pi/4. All right. So having this visual here, again, helps you from telling me it was 3pi/4. 3pi/4 is out of our restrictions of our domain, okay? So if you're just looking at your entire unit circle that you produced, just be careful on the test that when you're looking through it and you're like, oh, it's here and here, cool, got both answers. And again, like I said, it just happens on the test. I guess it's just one of those things where you're just so used to just pulling things from the unit circle. Okay, where is sine √3/2? 3. Where is sine -1/2? Super simple when it's right in front of you. On the test, majority will put 11 pi over 6. Trust me. Just make sure you write it. And then where is sine root 2, negative root 2 over 2? Uh-huh. And where is sine 0? So I have a couple of kids, sometimes they'll put 0, and a couple of them that will put 2 pi. Be careful. 2 pi is over here. Not within my inverse. Okay. Any questions so far? Okay, let's do cosine. Go ahead and graph cosine just like we did sine. All right, hopefully yours is drawn better than mine. It's kind of like squished off to the side there. Where does it look like we can cut off our domain so we remain in our restrictions? And it's 1 to 1. Do it.
That's right. No, because isn't negative pi over 2 supposed to be 0?
What do you say?
Oh, yeah. Yeah. Negative pi over 2 should be 0, and negative pi should be negative.
Oh, I missed a spot. It's like I wondered why mine looked so like lumpy there. How many people do you think this might mess with?
Please don't do that. And was like, but I see the curve, and that's all.
Perfect.
Oh my god.
Looks great. That's how y'all do things, right?
No.
Yeah, but like we have no respect for you.
Whoa.
Okay, there's that.
Just erase the one that was right. That was
Oh,
wrong.
jeez, you got me.
This is why.
I can't do anything right for y'all. Oh, now this one's wrong color. Man. Lenny's about to lose her mind over here because it's still going. Try to stop me now.
What are you doing?
Perfect.
Is that what that is?
Uh-huh. Perfection. Whoops.
Oh no.
Why do you have 2? That was fast.
Look at me go, y'all. Watch this. Lenny, you ready? You feel better? Okay. All right, so what can I restrict my domain to?
Is it 0 to pi?
Oh, yeah,
0 to pi. If you looked anywhere down the notes, it's already listed. So yes, 0 to pi. So no, this is not 1 to 1. And we are going to restrict it from 0 to pi. So that's going to be our first and second quadrant. The good news is we don't have to change anything to negatives. Okay. So still we're going to write out our And of course you can see it as arc cosine. We're going to write out our little mini unit circles onto the side. Like built-in extra practice with that unit circle. Once you've mapped out your first and second quadrants, you can go ahead and attempt these 5 examples.
You okay?
All right, do I have 5 different volunteers want to write up their answers?
If we say no, do we have to?
Okay, which one do you want?
One.
Okay. Let me change the color for you real quick. The board's messed up. What color you want? Purple, red, green, blue, black? All right. You just don't put your hand on the board because it registers that. Okay.
Interesting neighborhood.
All right.
Yeah.
It's like a little table.
That's how I've always done it, I don't know.
Hey, I like it.
Yeah.
It looks like pie to me. I'm the one grading it. All right, 3 more people.
I'm not gonna force it, if they read it out,
All right.
And you might
Ah.
so. He just blocked me.
boy.
I can forget it still, man.
You got your phone?
Yeah, you're already saying info.
What? You were there.
Because it's like so much work to walk up to the board.
You did the worst part of getting up.
You have to do it. 6 more steps.
Yay.
Go after game.
Where is cosine 0?
That's my answer.
That's okay. Look.
Final answer.
Did I show you?
No.
Okay, cool.
Alright. See, that was so hard, huh?
All right, so first one, cosine. Where is cosine negative root 2 over 2? Over here at 3 pi over 4. Where is cosine root 3 over 2? That's over here at pi over 6. Where is cosine negative 1/2? It's over at 2 pi over 3. Where is cosine 0? Pi over 2. And where is cosine negative 1? And that's it. Okay. Any questions? All right, so we've done sine, we've done cosine. We're just going to do tangent. Don't worry, the other 3 we're not doing inverses of. Okay, we're not doing cosecant, secant, cotangent. Just going to do tangent. Okay, I'm already telling you it's not 1-to-1 because I think you already know that. If I have all those squiggles, then I'm definitely not going to pass the horizontal line test. Okay, so see if you can from memory graph the tangent function. I probably should have told you that before, I'm sorry. If they attempted it, that's what I wanted to see. But
Yeah, that was looking pretty, nobody did that.
It'll be the other way. It'll be the other way. I guess it should be. Don't say that. Literally has it.
So tangent is y over x, and we've got 0, undefined, 0, undefined. So we're undefined in our pi over 2's. And we're 0 everywhere in between. And remember, we look at that first quadrant, we want to make sure we're in the positives for that. Okay, so where does it look like we can restrict our domain on this one?
Negative pi over 2, pi over 2.
Right. So it's going to look a lot like our sine function. Oh, whoops. I've already made a mistake. Why did I make a mistake?
Because you don't know what you're doing.
Dang, bro.
Jesus.
Who asked?
It's not brackets, it's parentheses because it's the asymptote.
Well, then why'd you make a mistake?
So we could catch it.
Interesting. Parentheses, yes. It does not include it because we have an asymptote there. Okay?
I'm gonna your throat today.
All right, so we're going to set up the same first and fourth quadrant. It's going to include those negatives again.
Good.
Wants to do the one for mom.
Yeah, go ahead and try. Definitely do 11 through 13, but give 14 and 15 a shot. if we're looking for where is, that kind of looks like it connects there, that's a negative. Where tangent is negative root 3, that's at negative pi over 3. Where is tangent negative 1? It's down there at that negative pi over 4. And where is tangent 0? Again, it's at 0, not 2 pi. Okay? So again, those are all just pulling that information. Here's where you have to spend a little bit of time and practice, and that's with these compositions. Okay? So, looking at the first one. Does tangent of the inverse of 1/2 equal 1/2? Who thinks yes? Who thinks no? So 2 people voted.
Welcome to America.
Okay. Looking at this example, I'm asking myself the question, where is tangent 1/2? Just like compositions you did in Algebra 2, where you took an equation, you plugged it into another. Okay, you always dealt with the inside first, and then you worked outwards from there. Okay, just like, please excuse my dear Sally. Okay, if I want to know where is tangent 1/2, that's not on my unit circle. But I know that if I'm dealing with the inverse, I can only be in the first and fourth quadrant, right? And tangent's positive up here, but negative down here. So it's going to be somewhere up in here where tangent's going to be 1/2. I don't know the exact amount, but I know it's going to be up there, okay? If I actually found what theta was, or where that was located, that's what would go right inside here. So pretend it was like 32 degrees or something. I don't know. Okay? Then I turn right around and say, what's tangent at 32 degrees? You would say 1/2. Okay? So yes, this one holds true because where it's located in the inverse world, I am allowed to be. Okay? More times than not, if it's in the spot that it's supposed to be in, you're good. You say yes, you move on. Or you would say 1/2 in this case. Okay? But let's look at something like 15. If I ask you, so this is when you have to keep in mind, am I evaluating where tangent is something, or am I evaluating tangent at something? All right? So what is tangent at 3 pi over 4? -1. So a lot of people would have been like, well, wait, you're not allowed to be at 3 pi over 4. I'm not asking you to find the inverse at 3 pi over 4. I'm telling you to evaluate what is tangent at 3 pi over 4. Now we turn around and say, where is tangent -1 on this? Negative pi over 4. So no, this is not true. So the whole purpose of this is to show you that just because you have an inverse and the actual trig function, they don't cancel each other out, and you just take what's inside. Okay? So we always work from the inside out, and we're going to do a few of those so that hopefully it clicks from there. Calculator-wise, y'all know where that button is in your calculator, right? Okay, we don't need to waste our time with that. I'd rather do the ones that we were just working on. Okay, so without a calculator, knowing what we know now, go ahead and evaluate these 4. Always work from the inside out. right, so if I want to know where is cosine 0.6, so if you look at it, in your first quadrant, cosine goes from 1 to 0. Okay, 0.6 is 6/10. We know it's not a whole. So we know that it's got to be here somewhere in this first quadrant. Whatever that equals, if I turned right around and said find cosine at that spot, of course it'd be 0.6. All right. So in this particular case, if I am where I'm allowed to be, which is in the first and second quadrant here, then it's just going to be that answer inside there. Okay. Y'all, usually 9 times out of 10, if that is what is written there, then it's going to be true. Okay, especially the ones that aren't on our unit circle. Okay. Well, they are technically on our unit circle. They're just not the normal lines we draw. Okay. So, what is sine at 3 pi over 2? -1. But then I turn around and ask myself the question, where is sine? -1. Okay, so it really messes with your mind there for a little bit, and you're like, wait, I was just there, it was 3 pi over 2, now it's -pi over 2. Okay. What is cosine at 2 pi? 1. But where is cosine? 1. 0. Oh, yeah. Okay. What is sine at 5 pi over 6? And where is sine 1/2?
6.
Pi over 6. Okay. Any questions on those so far? Okay. Try these 6. And yep, after these 6, we're done. the do you have like wherever you get everything stapled.
Oh, thank you.
Okay.
Well,
I just saw where you had submitted the review
yeah,
on Canvas, and I was gonna look to see if you didn't submit it with your work, right?
I'm pretty sure I did. I don't have it in here anymore.
Okay. Because I didn't know if you submitted it online,
I just saw
but
there
didn't
was
attach
some
it.
board online, so I did it.
Okay, but you also attached it to your,
Yeah.
okay, I just wanted to make sure you got credit for it, is what I was,
Yeah, I don't have it, so I assume it's.
okay, you probably attached it to it then. Alright, so 4 pi over 3. So we've got 1/3, 2/3, 3/3, so we're down here 4/3. So what is cosine down at 4/3? Do it. Thank you. And where is cosine negative 1/2? Negative 1/2? What'd you say? Okay, I thought you said just pi over 3. My fault. Oops. Okay, so if I asked you to evaluate cosine at pi over 15, pi over 15, of course, is going to be somewhere over here. If you notice, our denominators are getting smaller. So it'd be somewhere in here, allowed to be in there. So even if I did evaluate what that actual amount was, and then I turned right around and said, where is cosine that amount? Of course, it'd still be pi over 15. What does sine equal at pi? 0. But where is sine 0? 0. Where is sine pi? Be careful. Where is sine pi? Undefined. What does pi equal? 3.14 whatever, okay? Our sine and cosine graphs only go to negative 1 to 1. So if we're going to 3.14, again, some of us thought, oh, let's just figure out what sine is at pi. Again, you have to keep those little conversations in your head of where is sine pi? What is sine at pi? Okay, those little things. All right. Tangent at 2 pi over 3. 2 pi over 3 being over here. So then we would have negative root 3. But where is tangent negative root 3? Good. And the last one. Where is tangent root 5 over 2? That one's legal. Notice how we're going from where is tangent, or where do I find tangent, to, okay, now evaluate cosine at that. Okay? Hopefully, at some point, that starts triggering in your mind a triangle. Okay? Because if you think about it, every time I gave you something like tangent or sine or whatever is equal to 1/4, then you drew a triangle and then you found the rest of the 6 trig functions. So I'm telling you what tangent equals, but then I want you to turn around in that same spot and find cosine. So if you see one like this where there are different trig functions, that should trigger for you to draw a triangle. Okay? So if it's the inverse of tangent and it's positive, I can only be in the first quadrant. The tangent in general, I'm in the first and fourth. Since it's positive, I'm in the first quadrant. Tangent is my opposite over adjacent. And then they want me at that same spot to evaluate cosine. So cosine, I need my adjacent, then I also need my hypotenuse. So the square root of 9 gets me 3. Okay, so if they ever had two separate trig functions, and it's something weird like root 5 over 2 or 2/3 or whatever that's not on our unit circle like normal, automatically triangle, okay? It should look unfamiliar to you. And if it looks unfamiliar, do a triangle. All right, any questions?